So I have all my components laid out before me for the X3s, and I even have a few extras here sitting here that I'll get to a little later. So let's just jump right in and start building this thing. First thing I'm going to do is I'm going to unwrap this extrusion. Okay. And I think I'm going to get my lovely assistant off camera to remove some of that protective film off of the acrylic to save me some time. That one is straight. And that one is straight. Perfect. This printer's so big. Okay, so let's take a look at these guys. Okay, so we're going to need these four guys. Oh, that was nice of them. They sent some, I rarely ever, like I've gone on in my past videos, I hate these angle brackets because these slots are huge and the screws fall right through. And this is the first time, and I only get these with Tronxy printers. My X3, all the X3s I've built came with them, and the X1 came with them. But this is the first time I've ever gotten one that actually came with washers to go in there to prevent that. They might have put a little more thought into this version of the X3 as to compare to the original. Okay, so I'm going to need these four brackets. We're going to need some. Again, there's things mixed into bags together still, but not as bad as the X3 or the X1. So we're going to need some peanuts that are mixed in here with all these screws. 1, 2, 3, 4, 5, 6, 7. You can tell by the base of this printer how big it's going to be. I'm going to take some measurements of all this extrusion by the end of the build video, and I'm going to post that information in the description of the video for anybody out there that might be interested in purchasing themselves some 2020 and enlarging their own X3. And I did have somebody inquire about that, so I will take some measurements for all these pieces of extrusion. I'll write them down, and I'll write I'll make a list, and I'll write the measurements in each for each corresponding piece and where they go. I might get into more detail and note the hole positions in the pieces. But, if we get an idea of how big this is going to be, it's 530 that way, and just under 500 in that direction. So that doesn't count the gantry, how big the gantry is going to be, because the gantry is longer than those things, plus it's going to have two brackets hanging off the end to about here. Okay, enough of my rambling. Actually, those aren't needed for this. Loosen up these grub screws. back out some of these grub screws. I can't.
I'll come to you in just a second.
Fix that. This bag right here.
All that?
Yep.
Okay. Hello.
So, what I like to do with these little inserts is I'll tighten them both up, and you'll notice after you've tightened the second one up, it actually pushes the extrusion out and you'll have a little gap, and that's where you back off the first one and slide the extrusion down and close that gap and then tighten it back up. Okay, so there we go. That is step one. So these are going to be the bottom of these of the base. They're going to help hold it square, and they're going to have on the inside this little opening here, and it's going to be for our feet right there. So my assistant off camera is still working through a lot of the other acrylic. This stuff is time consuming, so I figured she did manage to do one up for me. Do the other three. It might be, the steps in the manual might be a little different than how I do it. In the end, all that matters is that it gets done, and it gets done right, and it's a functional printer.
But
Just set them right there. And if you want, you can take that stuff there for me.
it won't take long to do. I'll send her.
Okay, so that's our base together. Make sure there's nothing loose in there. Sometimes these cheap key nuts don't catch. One thing I would like to point out, with the base extrusion, there is a top and a bottom side, and the only way you can tell as if by looking at the holes. On the bottom side, the outer area of the hole has a counter bore on all four, but on the top side you'll find no counter bores. And the counter bores are to allow screws, the heads of screws, to sit recessed in the extrusion. So there is a top and a bottom, so when you're putting it together, just make sure for one, all your bottom pieces are facing down and that your feet are on that side. And that your bottom pads are on that side. Okay, so for my next step here, I'm going to go and install my tower pieces. I should have some screws here to go in there. And we need our I took a quick break to look at the instructions. I'm going to have to install these feet as my next step. But first I'll finish putting these angle brackets in place, and then I'll move on to those feet. Because until I can go any further, I need these feet in place to allow me to install my Y-axis motor. So let's get these installed. Next step is we got to put those feet in place so that we can put our Y-axis motor on, and then we assemble our slot wheels to Y carriage. Fellow 3D printer enthusiast on Facebook messaged me a little earlier while I was on break about the belts to let me know that they're actually a lot higher quality belt than you'd find on your typical low-end 3D printer kit. They actually have metal woven into them. So there's strips of metal all the way down the belt. So they're metal reinforced, these belts, which is really, really nice. Especially considering the price point of this. I can actually see the tips of the wire, or the metal that's running through the belt. Like a small piece here. Holy crap. And that's shot across the room. Yeah, so there's 6 strands going the length of the belt. So that's really nice. This is not just your cheap plastic belt. It's not your fiber reinforced belt, it's your metal reinforced belt. So I thought I'd check that out. Which one I need. These are for my gantry. This is the one I need right there. Okay. So the instructions tell me to install this like this on the inside, and our end stop is right up here somewhere, about 4 or 5 inches in. So what I'm going to do is I'm not going to install this like this, because I'm thinking of things I could do down the road to this printer. Like when the original X3, I made the bed bigger. So I'm thinking I'm going to put the Y-axis motor on like that, and that's going to give me close to 75 more millimeter of travel, and I can move the end stop back further, and it shouldn't affect anything. So we're going to do that. We're going to see how that works out. I don't think I'll have any problems there. I just thought I'd mention that if anybody questions my build, telling me I'm putting this on wrong, it's intentional. I'm going to put it on this side on purpose to allow me a lot more travel in this direction. So maybe I might find a bed that I could put on that heated plate further down the road to give me a much bigger print area without actually costing me a whole lot of anything. We need little tiny screws. So what they did, there's still a mix of hardware in each bag, but each bag would contain all of one style. So this would be all your M3s, but you would have your 6mm, your 10mm, your 20, and so on in there. It's a step up from what you have to work with from the X3, where everything's in one bag. And again, I know this isn't the right location for this. It should be on the inside, but I'm putting it on the outside to give me the option in the future to increase my bed. I'll have more travel. And this assembly just simply goes here like this, and I'm gonna belt tensioner for here, because this just screws in right there, and to me that it doesn't even allow you to get any initial tension on that belt at all. So this is just a poor design. So I do plan on designing something for there. I don't know, I might take a break from the printer right now and go design something up and print it up for right here. And it shouldn't be too difficult to come up with something. So back from my little break, and I have a new design here. that I specifically made to suit this printer. It's going to go in the front right there, and it's going to take the place of the pulley that goes right there. So it's going to allow me to have belt tensioning on the y-axis. This will be available on Thingiverse. Before the video gets posted, I'll make sure this model is available on Thingiverse for anybody that would like to print it out for the printer for themselves. The next step in the assembly calls out to install our bed rails, but I'm going to set them aside for a moment and get this assembly here set up on the printer so that I can position this center-wise. What I should do, and I will modify this, but I'm going to put a hole straight through the center here so that you can line it up with the center hole here on the printer. But for now, I'm just going to make do by measuring in and making sure I get it bang on center. But I will put a hole straight through here so you can use that center hole in the extrusion for positioning. So I do have a measuring tape here somewhere. Down a little bit for a moment, and we'll take the measurement in here. So that's at 210. As I said, I'm going to make this much easier in the final design with the through hole to I'm using a 1032 screw here, and you can use M4s or a thinner screw that'll slide right through here, and there is a space in there for a nut to lock it in place. But if you do use this, if you use a 1032, which is what I have available to me, the hole is small enough that it'll screw through and stay tight. It's going to go through there and through there. So I'm going to set these three pieces aside. I won't be ready for them until I have my bed in place and I set up my belt. So with this in place, now I can now put my rails in place. set those there for now. Remove the protective film from our Y carriage. Snug. Before I lock these down permanently, there, I'm gonna set up my T-nuts. So I ended up getting a distance of 164 millimeter in from edge to edge. Okay, let's grab some belt here. Here. Get going here. comes with quite a few zip ties. There's 20, at least 20, if not 30 in the bag. There's 2 lengths of belt, and they give you lots of belt to spare between the 2 of them. The other one is here. They're both the same length. So there's lots of belt to spare. that much extra belt. Foot is loose. I only hand tightened it. Go. Just gonna have to clip that. I don't know what that is there. It's happening. And that's how hard that belt is. With the steel reinforced fiber inside. Just broke. So you know this stuff's not going to stretch. What is that? I have no idea what that sound is. What am I rubbing? I'm probably rubbing up here. Okay, there's our Y carriage installed, and I got a weird sound up this way. I can't figure out what it is. Okay. Next, we're going to need a couple of our angle brackets. And our two Z-axis motors. 14 nuts. And 4 screws. Get some Captain tape and cap. And I'm going to put some Captain tape over the welded seams as well. I'm going to pick up some corking board too and two-sided tape it to the back of this to help it heat up faster and be more energy efficient. I don't have any right now, I'm out. I'll probably pick up some tomorrow. You know, and there will be some corking. I'll probably pick up some tomorrow since I'm doing this build in my spare time, spending an hour here and there on it in the evening. So tomorrow I'll pick up some. So by the end of the build there will be cork board on the bottom of this heated bed. So I took a little break. I stepped out to pick up some cork board for backing on my heated bed. And this is what I picked up at my local dollar store. I get 2 in a package for $3. It's 12 inches by 12 inches. It won't be enough. It was enough to cover the entire bottom of my CR10, but I don't think it'll be enough to cover the entire bottom of this heated bed here. It will insulate most of the underside of the bed and keep the heat from radiating away. This is a big loss of heat, this area, and if you insulate it, you'll prevent this. Your bed will heat up faster and it'll be less strenuous on your electronics, your power supply, and it'll cost you less in the long run to keep this bed going. Electricity wise, right. And all it is a couple of dollars out of pocket to do this. One side is a little rougher than the other on this one, so just clean it up, all the loose pieces off it so that we get good adhesion with our tape. Usually I apply my tape to the bed and then put the corking down and trim away the excess corking. In this situation I'm not going to have excess corking, so I'm going to apply the tape to the corking. I'm using 3M 300 LSE branded tape. So remember the 300 LSE. It comes in roll form or sheet form like this. It's really good stuff. I've got it on 3 of my printers. It doesn't come off. It holds the corking on quite well. It's very thin material also. my corking is on the back side of the bed, and I have the bed in place. And on our acrylic Y carriage here, we have four sets of mounting points here, here, and two in the front, so it doesn't matter which way you put this down. But I utilized one of those sets. I put on a zip tie, you know, pin that up here. I used a zip tie to route my heated bed wiring over to those mounting points. That way, see, I'm pulling on that, I'm not putting any strain here at all, and it keeps my wiring for my heated bed away from this assembly here. Because of the way this assembly is, because it's not turning the other direction, it's easy to catch our wiring there if it was still running straight down here. So if you route the wiring to either side, you can avoid the center assembly altogether. The next step of our assembly is our gantry pieces, and mainly the first of that would be our two pieces that mount to our towers. So we're going to need these four brackets here, these two printed pieces. They're the only printed pieces that come with the printer. They're exactly the same as the ones you'll find on the X3 itself. This whole assembly that I'm going to be putting together right now is exactly the same as on the X3. We're going to have our two L brackets, and I have some screws already picked out here and some nuts. We need our 6 of our longest screws that come with the kit. 6 plastic standoffs. And they're all over the place. Brass fittings. Screws and stuff for the brass fittings are up here. And our V-groove wheels. 6 V-groove wheels. When you install your brass fittings into these printed pieces, what you want to do, at least for now, is put them in loose, screw them in loose so there's some adjustment on them. And when you have the printer 100% assembled and ready to do your testing and your calibrations, before you go to those things, you check your threaded rod, you make sure there's no binding on one or the other, and then it goes up and down smooth. When you've got that all figured out, then tighten these up. flip this back around. This thing's so huge. Okay, I've been debating on installing this thing and doing some prints without any filament cooling, but we know how that turns out anyways. We always know how that turns out, so I might end up just going ahead right now and putting my upgraded hot end on here from my hot swappable tooling, and just so I have filament cooling right out the gate. So that would require me to take this whole assembly apart, which I have no problem doing. If you are wondering what I'm referring to when I mention quick change tooling, you can just take a look through my past videos. You'll find a video on the Tronxy X3 where I've designed a new back plate for it that allows for one screw connect tooling and plug and play wiring. I'm not going to do the plug and play wiring on this, not now anyways. I just want to have a hot end on here that has filament cooling. And not one of the all metal frame Tron XY printers come with filament cooling. The X1, the X3, and the X3s, none of them come with filament cooling. This hot end also blows on the entire heater block, as with the other two printers I just mentioned. This is the exact same, so you're going to want to correct that right away as well. What you could do, if you don't have another printer to print anything out on, you could just tape up half of the fan shroud here to reduce the cooling capacity of the fan and print out your upgrade that way. So these wires are so long that they've actually spliced them with some heat shrink tubing here. So this entire assembly, including the fan, I'm going to set aside. I won't need. I might rob the wiring from this fan, just because of how long it is. But in the end, I'm going to have it set up like this. So I got my cooling fan from the side onto the heat sink, and it's not blowing on the hot end at all. And then I got my filament cooling in a 180 pattern here. If you're somebody that uses auto bed leveling, I do have some mount points here for auto bed leveling sensor. Anyways, it'll be in silver, and it'll be my new modified version that has the ability to hook up a cable chain to it. So just future proofing it. First thing we're going to do is we're going to take this back plate and we're going to mount it to this back plate. It's basically an adapter that allows all the different tooling that I have. Okay. That's good. Okay, now let's get the Bowden tube out of there for a minute. I am going to have to splice this wire to make it longer to match the others. Goes like that. We even have a spare of these. Maybe they're just putting in some of the same acrylic that comes in the normal X3, because the X3 has two of these, one for the front, one for the Y-axis, and one for the X-axis. We have our X-axis end stop, our Y-axis end stop, or sorry, Z-axis end stop, Y-axis end stop. I'll set those up next. We're just going to put this in all the way to the extrusion, and then we're going to route our belt, and then we'll pull it out to tension it. Here's another long length of belt. this around so I can see what I'm doing, and you guys can get a good shot of the custom on-in that I put on there. Steel reinforced belt. Very hard to cut. And they give you more than enough belt. I've got an extra almost 3 feet here. So we're going to hook up all our stepper motor wires, and they're all labeled, so it'll make it convenient for us to figure it out when we go to hook it up in the electronics box. Just make sure this little label is on the opposite end of the motor so you know what it's for. This one really long one, which has E on it, is for our extruder. Then we have our Z axis. So we're gonna have to do something about that. You see here how that caught in front there. So all my wires are connected to the printer. I took some time off camera just to put everything in some cable wrap. So that's very it's not too exciting to watch. I still have I find these are coming out really easy. They don't stay in the motors very well. Have to figure something there. We'll take a look around the printer once everything's complete to see how I set everything up, see how it turned out before we do our first test print. I still have my X-axis stepper and end stop wires to wrap. I will say this is the first printer kit I've ever gotten where I've had more than enough cable wrap for everything. Usually I'm using some of my own. I still have a length left to do my last two wires, but I'm gonna pause, go off camera for a minute, move the printer aside, clean up my work area here, and get set up to do the electronics box. We'll zoom in for a closer look as I do the electronics box, and once that's done, we'll marry the two together. Okay, so we're all set up to put our electronics housing together. I'm going to make one modification here, which is the part I had to purchase. Is a MOSFET is going to go in there, given the fact that this printer is a little higher end of a kit and costs a little more than your more budget-oriented kits. I do want to add a MOSFET right off the bat during the build. So we're going to grab our plate, our base plate for all of our electronics. I'm going to go on here. Let's look at some plastic there. So we have this guy here goes on like this. But we're not putting that on yet. Our Tronxy name is right. Organize this a little better. There. Just gonna line up with this. I'm gonna get some screws here. See how this goes. Our board is going to mount right here, and I'm going to check to see if I have space. I believe I might have space near the back right here for my MOSFET. If not, I'll reposition the board up this way further. So to minimize the amount of holes I have to drill, I'm going to use this slot, and that just leaves me 2 holes here, and hopefully I have enough clearance for my wires. So this one here is going to go right to our power supply. This one here goes out to the heated bed, and then you have 2 options here with this particular MOSFET that I purchased. You have one that wires to the bed on the board, or you have another one that has a special switch that you can wire to like an Arduino or whatever. We're gonna use this one here on this side. I don't know if the holes I drilled are big enough. They're just I might have to go through with a slightly larger drill bit. This is going to go right here. But before I do anything, I'm going to put some wiring in here so I can get access to it. The heated bed is going to be difficult to wire there, I think. It'll be easy to wire off, but if I install this right now, it'll be difficult to wire. So we're gonna what I'm gonna do is just go screw it in place for now, not tight, just loose, and then finish putting the rest of this housing together. And then when I bring the printer back up on the table, I'll take this off and wire everything up. Something unusual I noticed about one of the side panels here for the front, it's got a cutout as if there's an SD card slot on this, but there's not. So I'm not sure what that's there for. It's not on any other X3 printers I've had. So I'm not sure what that slot is for. Somebody knows, they can comment, but I think it's just a universal thing. And as I said, there are 2 connectors on the back of the panel. And if you'll see here, very carefully, you'll see the outline, the pins in the outline for where you can mount a full-size SD card slot. And that's what one of these will be for. So I'm not sure why I need that extra slot there. I don't. So this is the reason why there's one of these. This second one is here. It's for this pinouts. I don't think we'll need it on the board because the board has a micro SD card slot. The board has both connectors, so the board probably supports the micro SD on the board plus the full-size SD card here if we would have one. But even with this slot here, this is so far away we would never be able to reach it. Okay, I took a quick look at the manual, and the one closest to the pinouts for an SD card slot are the one hooked to the one closest to the micro SD card on the circuit board. Now this is weird. The connectors are recessed too far to allow me to open this door to get access to the screws properly on this power supply. What I'll do is run my heated bed through here so I can finish off this MOSFET and mount it in place. our box all wired. So I'm not going to put the top on yet until we fire it up and make sure everything's working. So let's clear up some of this mess here and see if everything turns on like it should. Make sure all my connections are tight. I think I'm going to do a cable chain setup on this because I'm worried about this belt catching under the bed here. If I do a cable chain setup, I could have it so that it forces this to go like that, maybe. So let's heat the bed up. I want to see how far over while I'm doing this. I can go on my x-axis in the software because I know I have movement-wise on the bed at least 20 mil on either side of that bed. So let's see if we can do let's see what our range of motion is. I'm struggling here on my z-axis, so I'm going to have to look at that and see what's going on there. There's something wrong there. Okay, I don't know how well we can make this out on camera, but I'm struggling quite a bit with the threaded rods here. It's just, the printer is so big for a kit, and everything has to be lined up so perfectly or else you're going to get them fighting each other, and I really had an issue with that. I'm hoping I've overcome it here a bit, but one thing I'm taking this quick video to show is how well that filament is laying down there. So this composite, I'm not sure what it's made of, but what I did is I sanded it with some 420 grit and cleaned it up, and my filament is sticking to it like it would stick to a sheet of PEI. So if that is the case and this works like a sheet of PEI, then that's a really nice bonus, because a sheet of PEI, even a 12-inch by 12-inch, usually runs like $20–25. And another reason I'm doing this retarded looking print is this bed, as I said, is 330 by 330. The software, the Marlin software that's set up on the board has limits of 355 by 355. Made up a model and I did 320 by 320. What you're seeing here on the outer edge is the primer line. which is going beyond 320. And but it's printing. It's printing on this bed. My big concern right now are these wires. They're so long and they're wanting to catch in these front corners. So I'm definitely going to do use the other shroud I made up that has cable chain hook up here, and I'm going to print I already have a model design that I'm going to put here so that I have a cable chain there to keep this from flopping around. There is an offset built into this firmware on the x-axis of -22, which it did take a good 13 minutes to 14 minutes for that bed to heat up, and it probably would have taken a lot longer if I hadn't had that corking under there. This is a big build air. This is a big heated plate. It's at 330 by 330. It's going to take a while to heat up with the smaller power supply and running at 12 volt, but it did take 12 to 13 minutes for that to heat up. So I'd like to point out, here's my board, power supply, my MOSFET powering the bed, all working away there, nice and cool. Everything's all screwed in place, and I now can put the lid on this. So we've reached the end of the build video. The printer's all assembled, and I finally managed to get a successful print. My first attempt here, I have shifting on my y-axis. I'm not sure 100% what caused. The print was coming out really well. There's a lot of detail in it. And then I had 3 attempts at these whistles, and the same shifting, even worse. So I took a look at my pulley wheel for my y-axis. The grub screws seemed tight, but I tightened them up even more as much as I could. And then my 4th attempt at the whistle worked out. So I'm hoping that that's all it was. We'll find out with some future prints. The whistles are a little rough looking. I did print them at 0.3 mil layer height, but we'll see what kind of quality we can get out of this printer in the next few weeks. I'd like to go over right now some of the things that I've come across in the build. So the first thing I'd like to mention are these threaded rods. They looked straight to me in the unboxing and the initial build, but then I noticed with the whistles that this one here actually has a slight bow to it. If I hold the ruler up here, my center is out about 1.5 mil deflection, and I was really having a hard time getting it so that that Z-stepper motor wouldn't bind up. So I've had the printer apart and back together now, the whole tower assembly, 3 or 4 times. I've went over and over and over again, lining up everything from the top to the bottom, trying to get it perfect. It still wasn't working. For this print, I actually loosened up my brass fitting on that side, and that seemed to work because it allowed the threaded rod to do the travel that it wanted to do due to its bend. Right now, I have my brass fittings are all tightened down, and what I did 2 things. I took my couplers and I made sure that only for my shaft of my Z-stepper motors and my threaded rods that they were just in enough for the grub screws to grab. That's a tip I got from another reviewer who's doing a review right now as well on the printer, a written review. And then what I did is I lowered my L brackets here down about 1/4 inch past the base so I'm down farther below the bed, because my real issue with that motor binding up over there was down around the first half inch to 3/4 of an inch above the build plate. Up here it seemed fine, but when I would get down around here, I would start binding up over there. Doing these two things helped mitigate that a lot. In the end, I'll probably end up just replacing that threaded rod just to see how everything goes. But right now, everything seems to be working fine. And again, that's an issue that I got with this printer that might not be with your printer. It might not be a typical problem with this printer. It just might be my luck of the draw. A couple other things I had issues with, and they're not big things. And again, it's the luck of the draw. For my stepper motors, the connectors that go into them, 3 of them, they're loose and they can easily fall out. And I've had that on other printers before, and even stepper motors that I've bought. And so it's not a big deal, but I just thought I'd mention it. And the other thing I have an issue with is the power connector plugging into the wall to the back of the box. Either the power connector or the little fitting that it plugs into that you can turn on and off, they don't fit snug. And I have others that fit very snug and I have no worries, but that doesn't fit snug. If I move the control box just a little bit, or if I shake the table, I risk losing power for a brief second and I'd ruin a print. That's easily fixed as well, but those are just things that I've run into with this build. The thing I struggled with the most was the threaded rod assemblies here. And it was mostly this one over here, and again, I didn't realize I had the bend till near the end of the build here. And it really caused me some issues, because I took this whole assembly off a couple of times. Really stretched out the time it took me to get this build complete and get this video finished. But right now everything's working. I'm getting prints, and we'll continue printing to see how everything goes. But I will say this, other than that slight bend, I have no real quality control issues with this printer. I have extra screws, I have extra nuts, I even have extra bed springs in the kit. There was more than enough zip ties, more than enough wire clamps, and more than enough wire wrap for all those wires. It comes with a generous, how can I put this? The wiring supplied with the printer is generously long. So you shouldn't have to worry about reach, whether it's on your x-axis going up or to your bed. Most of the wiring is 6 feet or 7 feet. So the wiring is generously long. Without the corking I have under here, this heated bed takes close to 20 minutes to heat up. And even with the corking, it's taking me 13 and a half minutes for this to heat up. So similar issue to the CR10, only a little more severe. But that would be a given the fact that the heated bed is slightly bigger. I do recommend everybody out there, buy yourself a MOSFET. If you're going to buy a printer of this size and you're going to take the time, put it together and have some pride in it, buy a MOSFET, put it in that box, hook it up to this heated bed, just doing, just for a safety factor for yourself. For $300 US, when you can get this printer on sale, I think it's a really good value. You're not going to get a printer with this large a build volume for that price, kit or non-kit, anywhere else. I haven't seen it yet, and if I do, I'd like to get it in for review. All the upgrades I've done here, some of them are just superficial. They'll be on Thingiverse. I'll put those on Thingiverse before I even release this video. I wanted a cable chain on here just for the simple fact of how long the wiring is there. It doesn't come with filament cooling out of the box, and I think that all 3D printers should have filament cooling. Again, that's not a deal breaker. Set the printer up, print yourself a shroud, put that shroud on. I have designs available on Thingiverse that incorporate a blower style that you can put on this printer, but all my X3 shrouds you'll find on Thingiverse, and anybody else's X3 shrouds you'll find on Thingiverse will fit this printer. The only X3 upgrades on Thingiverse that you'll find that will not be meant for this printer will be your Y tensioning. and you'll find this new Y tensioning adapter of mine on Thingiverse that'll allow you to do a belt tensioning on your Y axis. And another thing I'd like to reiterate is that these belts are steel reinforced. So I got some end caps here. They have the X3s branding in them. I just thought it would be a neat feature to the printer. Plus the extrusions are sharp on the edges, so those will be on Thingiverse, and they fit snugly on the ends of the printer. You just tap them in place. You can pop those on not only just for visual, but it'd be a safety feature as well if you risk cutting your hand if you're working on a printer or whatnot. I have a 250 by 250 millimeter glass bed on here. I accidentally chipped it because I left the screws in one of these bearings loose trying to figure out what my issue was with my threaded rods, and when I went to do a print, the screw fell out, chipped the mirror. It's not a big deal. It's not that expensive to replace if I have to replace it. The firmware and the frame do allow you to do a full 350 by 350 millimeter range on this printer, so it is easily possible to print up to 350 by 350 on this printer. I don't know, there's not much else I could say right now about the printer. Up until the point where I was getting frustrated over these threaded rods, I really did enjoy building this printer. I love my original X3. It was one of my first kits that was non-Delta style. My printers before that were all Delta style, even my homemade ones. And I really, I had lots of great prints off that printer. I still do to this day. And I was really looking forward to getting this version, as I think it's a significant upgrade over that printer. If you check out one of my previous videos, you'll see that I did some quick tooling and laser engraving abilities for the original X3. All those upgrades can easily be applied to this printer. I already printed the backplate, it's on there, and I could easily change out tooling now. So if you want to do that to this printer, you can easily do that. You can laser engrave on this massive bed as well as 3D print. It's all in the previous video of mine if you want to look that up. I'll put that in the links below as well. I'll put in the links all these models that you can find on Thingiverse. I'll put a link in the description of the MOSFET I purchased on there. It's I got it off AliExpress. It's not an affiliate link or anything. And there will be a link in the description to where you can get this printer. That is an affiliate link. It can be picked up at GearBest. You can pick it up on AliExpress as well. I haven't seen it as cheap on AliExpress. The cheapest I've seen it on AliExpress is $460, $466 US, and that's still $66 more than the regular price on GearBest. While there is a coupon code, or when one pops up, and while it lasts, I'll put one in the description below. So, thanks for watching the video. I hope you enjoyed it. I really look forward to doing some prints on this printer, tweaking it, seeing what kind of quality I can get out of it. So that's it for now. If you enjoyed the video, please subscribe. And stay tuned for a follow-up.